At point P, the perimeter is P. Okay, so the equation of the tangent at point P can be expressed in terms of this, where I replace T by P. Okay, so the equation of tangent is y is equal to 2p to the power of 3 is equal to p x minus 3p squared. I can do likewise for the tangent at Q, because according to the question at point Q, the perimeter is Q. Okay, so the equation of tangent is going to be y minus 2q to the power of 3 is equal to q x minus 3q squared. And these two tangents, they are going to cut at the point R. We want to find the x-coordinate of R and showing that it is equal to the expression p squared plus pq plus q squared. And to do that, we just simply need to solve this pair of simultaneous equation to solve for x. Okay, and that should be, what we will aim for is to show that it is p squared plus pq plus q squared. Okay, let's solve for this. I'm going to try to just take equation number 1 minus away equation number 2, okay, to get rid of y. So what I have is going to be minus 2p to the power of 3 minus 2q to the power of 3. This is p x minus 3p squared minus away q x minus 3q squared. What I have on this side, it is going to be equal to 2q to the power of 3 minus 2p to the power of 3. And what I have here is px minus 3p to the power of 3 minus qx plus 3q to the power of 3. Okay, so leaving this x on this side, it is going to be px minus qx. So bringing the rest over to the other side, what I have, bring this over, it is going to give me a p to the power of 3. Bring this over, it is going to give me a minus q to the power of 3. Okay, so I can re-express this, factorizing out x is going to be p minus q of x. This is going to be p to the power of 3 minus q to the power of 3. Okay, so x will simply be p to the power of 3 minus q to the power of 3 divided by p minus q. Okay, let's do a long division for this. Okay, so if I were to divide, okay, the numerator here, p to the power of 3 plus 0, p to the power of 2 plus 0, p minus q to the power of 3. I'm going to divide this by p minus q. Okay, so here I'm going to multiply by p squared. So multiplying this, it is p to the power of 3 minus p squared q. Okay, and what I have here, it is going to be a p squared q plus 0p. Okay, what I'm going to multiply here is plus pq. So multiplying this, it is going to give me a p squared q minus pq squared. Okay, so here is a pq squared minus q to the power of 3, and here it is going to be a plus q squared. So multiplying this, it is going to be p of q squared minus away q to the power of 3. Okay, and this is 0, which is good. Okay, it shows that p minus q is a factor. But anyway, this tells me that this is going to be the result of this division. That is why x here is equal to p squared plus pq plus q squared, okay, which is what the question wants me to prove. This is the x-coordinate of the point R. I also want to find the y-coordinate of the point R, and that is simple because we just need to sub the x-coordinate solution back into either equation number 1 or equation number 2. Okay, let's do it for, let's say, equation number 1. Okay, that means substituting this back into equation number 1, y is going to be equal to p of x, and x is equal to this, so this is p squared plus pq plus q squared, minus away 3p squared, then plus 2p to the power of 3. Okay, I'm shifting this over to the right hand side. So y over here is going to be, if I were to expand this, it is going to be equal to p multiplied by p to the power of 2 plus pq plus q squared minus away 3p squared plus 2p to the power of 3 This is p, this and this, it is going to be minus 2p square plus pq plus q square plus 2p to the power of 3. We're multiplying this in minus 2p to the power of 3 plus this, it is going to be p square q plus pq square plus 2p to the power of 3. Okay, and this disappear. So what I'm going to be left with is a p square q plus pq square. I can actually factorize out pq, and that will leave me with just a p plus q.